Alrighty. So we are going live. We are live. We are live. We are live.
Exciting.
Oh, yes. This is exciting. We are making history. We are making Data on Kubernetes history. This is incredible. Happy Monday to everyone. Very, very happy Monday. It's not typical that we do meetups on Mondays, but today is the perfect Monday to do so for multiple reasons. We've got quite a few things to celebrate. Raj Kumar, could you stop sharing your screen really quickly just while we do the intros?
I sure will do.
Okay, perfect. Anyway, welcome to everybody. Always good to be here. I am live from California, Vallejo, California. If you are not aware, it's an amazing city near San Francisco. And I'm joined by Raj Kumar, who is in Apeldoorn, Netherlands, a place that I love very, very much. It's a wonderful place, beautiful natural landscapes around there, a nice, delightful train that you can take, an old train around the area. Highly recommended when we can all travel again more easily once things start to calm down a little bit. But it's also exciting because we're celebrating a little bit later, but the 7th birthday of Kubernetes. So Kubernetes turned 7 today. We all remember our 7th birthdays. I know mine was a good one. I think I was dressed up like a Ninja Turtle. But anyway, it's really, really good to be here with everybody. As always, as well, too, we have different things going on. And one of the things that we have going on with Raj Kumar that we have not seen before, we have a lot of art in our community. We always have a lot of art in our community. Some music, things like that too. But he is also into drawing. So that's going to become an integral part of today. But we're not going to, no spoilers just yet. Raj Kumar, welcome to the Data on Kubernetes community. For all the folks out there, remember you can follow us on Twitter, LinkedIn, get in our Slack, check us out on YouTube. We're streaming live on YouTube. Ask questions in the chat. You can always ask questions in the chat to get conversations going there. More than happy to answer your questions here as well as in our Slack. That being said, Raj Kumar, welcome to the meetup. Welcome to the webinar. Tell us about yourself.
Thank you so much for having me today. Well, I really love the energy. And I think one of the bright things about having a lot of positive energy is that it is very contagious. So even though if I am perhaps very boring, I think this energy is already getting me up started. So thank you very much for having me. And about me, you can call me Raj. My full name is Raj Kumar Balakrishnan, but feel free to call me Raj. And I formerly was working for Royal Agrifirm Group, which is an agricultural company and focused on sustainability and bringing best farming practices to protect people and the planet. And what was I doing there? I was responsible for site reliability engineering. So that's what I was doing. So software engineer at heart and very comfortable with crisis response, and that's me in principle. As of today, I'm jobless, and I'm very happy to be engaging with all of you. And in a week's time, I'm quite excited to be joining Microsoft at their customer success team, to be working with the rest of the customer community in the Netherlands and helping them derive value out of Azure platform as a whole. All right, so this is me in principle, and outside work, I love to swim, and I'm also an amateur pianist, if I will. So that's me, basically.
That's cool. That's cool. All right, so pianist, do you play your own music, or you learn? Or did you compose? How did you start with piano? Tell me about that.
Well, I think I'm not that far yet. Right now, I'm quite decent in watching notes and following the notes through. So I'm not composing my music just yet, but I try to dabble and perform sheet music of like pop or any other Western.
That's good. That's good. Genre. That's good. That's good. Good way to stay busy. All right. Very, very good. And can you tell us about when did you start drawing on the iPad? How did that start?
Okay, so this happened when I had a chance to visit Switzerland in 2019 for actually a community event. And I thought, okay, I for a very long time wanted to buy an iPad, and I was passing by this Apple store, and for some reason there was some kind of discounts going on, and I thought, okay, this is the moment, let's go grab one. And when I picked it, I started doing my first presentation on my iPad, and it apparently worked very well. So I thought I could express myself much better when I could write rather than on a PPT template or so. So that's how it all started in 2019. And since then, I do all my notes or try to do as much as my presentations on the iPad by drawing and stuff.
Very, very good. Well, that being said, let's jump right in. If you want to share your screen so we can check out and see what you're drawing, go for it.
Absolutely. So I'm going to share my screen again.
Okay, perfect.
And say start broadcast.
All right, we got it. Good.
Sweet. And let's change the template so people could see not the lines, but a clean white page. Blank. Apply. All right. So for today's session, we were going to talk about Kubernetes. In general, Kubernetes is usually perceived to be very complex, and of course, I'm not denying it. It has a bunch of complexity to it, but I believe that should not be a barrier for people who are starting on their journey, on their learning journey towards Kubernetes. So today, the entirety of the idea is to make Kubernetes very accessible, break down what exactly is happening behind the screen in a bite-sized manner. So if you are already an expert and are already deploying pods and running your workloads on this platform, today is perhaps not the best day to derive a lot of insights. So the content of today's event is mostly targeted towards people who are starting their journey on Kubernetes and who are very new to it. So that's the entirety of the idea. So at the end of the session, let's see, right now it's 6:10 an hour, and maybe I think I might be able to run the session for the next 30 minutes at most. And what we are intending to cover is basically the principles behind Kubernetes as to why it is built the way it is built. And we're going to cover two principles. And then from why, we're going to move into what. So what exactly does all these principles are great, but how exactly are these principles translating into the definition of this platform? And then three, we're going to go through the usual concepts, the terminologies that you will keep coming across when you start your journey on the Kubernetes platform. And once we are done with all of this, I'm going to show you, take you into the Microsoft Cloud platform, which is Azure, and show you how you can spin up a Kubernetes cluster and how you would deploy your first container. So at the end of the session, if everything goes well, we will know why, what, how Kubernetes, and practically we would have logged in into the Azure platform, spun up the first Kubernetes cluster, and we would have deployed our first application. So this is the idea for today. And if that is all right, we are going to get started.
Let's do it. Let's do it.
Fantastic. So let's start with the name, Kubernetes. And as you might have seen, this is also written as K8S, and that's because there are 8 letters between K and S. So there's 4 here, there's 4 here. So the term Kubernetes is also written as K8 and S. And this word is being derived from the Greek mythology, the Greek language, and this refers to a person who is a pilot or a helmsman. Okay. So when you imagine a pilot or a helmsman, all you can think about is, okay, let's think about a ship here, and a ship which is being piloted by a captain, and these ships are carrying a lot of containers. And I would like to set this scene on your head, and we are going to translate this picture into the working components of Kubernetes. So Kubernetes is a container orchestration platform. It allows you to run containers, as simple as that. And when it comes to Azure Kubernetes Service, it's a fully managed container orchestration platform. Usually, if you were to spin up your own Kubernetes cluster, or you were to build your own Kubernetes cluster, there are a certain set of responsibilities which a person has to take care of, like patching my nodes, keeping the kernel up to date, and keeping the security aspects of my different systems, my nodes, in line with the latest releases and updates. And these kind of aspects are being abstracted away when you go to a fully managed service. So we just read about what Kubernetes is, and well, the terminology where it is being derived from, and what exactly is the definition behind the platform Kubernetes. Now we are going to talk about why Kubernetes, so why it is built the way it is built. While there are several design principles around the construction of Kubernetes as a platform, there are two things which we will look into today. So one is one of the driving principle for Kubernetes is workload portability. So the idea is I can run my compute, or I can run any of my job on Kubernetes, and I can take it from one container platform to another container platform absolutely with no hurdles. So one of the key principles that they had in mind is workloads that are running on Kubernetes has to be portable across any provider, any container orchestration provider. So this was the first fundamental principle. This was one of the fundamental principles. So what this does to us, basically, I'm not necessarily locked in with, be it Google or Amazon or Microsoft or any particular vendor per se, because the principle behind which my workload is being built and it is being deployed supports the principle of portability. So workload portability is one. And the second aspect that we will also go through in today's session is how the entirety of Kubernetes API, it is declarative. So when it comes to programming languages, there are several paradigms. So there are functional programming approaches, there are imperative programming approaches, and then there are also declarative programming approaches. When it comes, okay, so what exactly is the difference in here? When let's say I want to make a coffee in the morning. If I would tell someone, hey, you know what, you will have to wake up, go grab a cup and pour some milk, pour some coffee, put some sugar, and then mix it all up, warm it up, and give it to me. Then okay, so that's a very dreadful coffee, anyways. But I'm giving a step-by-step instruction on how to prepare coffee. And this is the imperative way of doing it. I'm giving instruction by instruction. But the way the Kubernetes API has been programmed is they are declarative. I do not say how to prepare coffee, but I say, you know, get me coffee. So I'm specifying a desired state, and I'm taking advantage of the platform to do the imperative instructions for me. Okay. So we started with what Kubernetes, where it is originating from, what is this K8s, and then we spoke about two design principles. One is workload portability, and the other one, what we spoke was how the platform supports a declarative way of doing things. Okay, now how do these principles, how does this platform come together? Basically, this is where we're going to start drawing, and we're going to talk through the, now that we've spoken about the what and why of Kubernetes, now we will see how this what and why is getting together in action. So basically, this container orchestration platform is nothing but a collection of computers. So computer 1, computer 2, computer 3. So we have a lot of computers, and on the top of this computer, there is this Kubernetes orchestration layer. And this Kubernetes orchestration layer is exposing a set of APIs, and these APIs are accessible via kubectl, which is our tool, and there are multiple ways of pronouncing it. All that it does is kubectl gives you an opportunity to interact with this API, and you can ask these APIs to do a set of things for you and what you can ask them to do. So there are there are several terminologies that you will come across when you talk about Kubernetes. So most of the times you will run your workload as containers, right? And these containers will run on an object called pods. So pods is the first terminology that you will very often come across when we talk about Kubernetes. So pods allows you to run one or multiple containers in a co-located workspace. So we have pods, and these pods are executed on the top of these computers through a Kubernetes object called deployment. A deployment, what it basically does, it is a YAML file, and it is a declarative instruction to the Kubernetes cluster as to what and how it needs to run those pods. So basically, the deployment object will have some instruction on how exactly the pods needs to run. Say, for example, when your workload, which is a container, which is running on a pod, is defined using a deployment object, and let's say you want 4 copies of your containers to be run, and therefore you're saying, okay, I want 4 copies of my pod to be running on the cluster, then the deployment object under the hood is going to use what we call as a replica set. So the user, I have an application, so I'm taking that application. Let's say, okay, this is the application of very bad application. So, and I'm going to kubectl API and say, hey, kubectl, let's write a deployment object. And the deployment object says, and this is going to be a YAML file, and that YAML file says, hey, okay, I have an API, I have a set of instruction. Okay, you need to deploy a pod, you need to deploy it with 4 replicas, and then it is going to be, okay, so it's going to deploy 4 replicas, and it is going to deploy my pod, which is my app1. And the moment this YAML file is being executed on the it is being executed via the kubectl API by saying kubectl apply EF and my YAML file. And these instructions will be picked up by the scheduler, and then those pods will start running on my containers. So now I will have app1, 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 because we said there are going to be 4 pods. So this is P1, P2, P3, and let's assume the 4th pod is also running on the 3rd computer. So for simplicity's sake, we're calling it computers, but in principle, what happens, these computers are not just bare metals. These computers will have some hypervisors running on the top of them, and those hypervisors will be running virtual machines, and those virtual machines will be running container runtime, and those container runtime will be capable of running these containers. Okay, so now so far we have seen how this user takes this package called app1, uses the kubectl API, writes a YAML deployment object, and deploys the app1 pod, defining 4 replica sets. So the deployment uses replica set to spin up 4 counter pods on the Kubernetes nodes. So these computers, what we call for simplicity's sake, in the Kubernetes world, they are called as nodes. So these nodes together, when they are at least on the context of Azure Kubernetes service, when these nodes fall under the same SKU, say same compute and memory, they form a node pool. So now, having said all of this, right now your application is running. Your application is containerized, and it is running as pod, as replicas on the top of this Kubernetes platform. Now, you just saw how exactly we are declaratively instructing the Kubernetes cluster that you need this app one in terms of 4 replica sets, and then the Kubernetes platform picks it up and does that for you. You do not say, okay, listen, Kubernetes cluster, you will have to take my app and run it on node 1, and you need to take another copy of the app and run it on node 2. You basically do not get into those finer instructions, but rather say what your desired state for your application is. Having said this, the app is getting deployed on your cluster. So we spoke about what Kubernetes, and we spoke about the why part of Kubernetes. That's basically the 2 principles. One is workload portability, and the other one is how we are giving declarative instructions. And on the how part, we spoke about few terminologies where we started with pods, we spoke about deployments, we spoke about replica sets for now, and we also briefly touched on nodes and how the entire platform exposes its API via a kubectl command. So this is so far the theory part. And we are already about 15 minutes through the session. And without further ado, we're going to get into the Azure platform and see how we can spin up this Kubernetes cluster and deploy our first YAML definition and see all of this work in action. So let's go ahead and do that. What I will do, Bart, I'll stop sharing my screen from the iPad and rather now go to my computer to show how the Kubernetes cluster works on the Azure platform.
All right, sounds good. Very, very nice introduction as well. Very, very helpful. You can never repeat these things too much. And also having the visual representation, fantastic.
Sweet. I really want this to be as simple as possible. So if there are any questions, please feel free to interrupt me and we'll get this further through. And I'm going to start sharing my screen again. Share screen, share. All righty. Okay, so do you get to see my screen?
Yep, you're good.
Perfect. All right, good. So if you've not seen this before, this is how the Azure Portal looks like. And let's say we want to get started with Kubernetes service. Now, there are several ways, irrespective of the cloud platform you go to. Each cloud platform exposes multiple ways to get started on their service offering. So there is always a CLI tooling, there are APIs through which you can interact, and there is also a UI through which you can interact with the platform. For the sake of simplicity, we are not going to do command line. We are rather going to go through the steps on the UI to see how the cluster is being constructed. So let's say I go ahead and tap on create a resource. And if you can see here, it is the Kubernetes service is right on the top under popular offers. If not, you can also search for it and click on Kubernetes service. And we're going to click on create. And there are several things that we need to start populating. So when it comes to the
sorry, Raj, really quickly, we got someone in the audience asking if you can just show the picture one more time really quickly so they can take a screenshot from your iPad.
Oh, yeah, sure.
Okay. If you don't mind just switching over really quickly.
Maybe what I can do, even better. Okay, first I will share the screen because they asked for it. And at the end of the session, we could share this as artifacts.
Okay.
Start broadcast. And notes.
Basically, you're a famous artist and you can't hide behind your fame. People need you.
Stop sharing. Okay. Do you see my? Oh, no, not happening. One more time. Okay.
Oh, there we go. Yep. Now we got it. I'm gonna take a picture of that
so
too.
Let's make it
I'm gonna take a screenshot of that
better.
too. That's good. All righty. I'm gonna tweet this.
And let's say the terminology. And then we say, okay, so
Oh,
that's mostly it.
That's even better. Getting some color. Yeah, I'm gonna retake that picture. Good, cool. All right, thank you very much.
All right. So we're gonna stop sharing one more time from my iPad. Okay, it's gone. And I'll start sharing from my PC. Okay. Share. Okay, so back to the Azure Portal screen. So we picked up the Kubernetes resource, and when I clicked on start creating a Kubernetes cluster for me, this is the first screen that says, okay, so if you're new to the Azure platform, and I assume you could be new, so I'll go with even finer and lower level of detailing. So the way every resource on the cloud platform is organized is at two levels. One, the fundamental unit on which all your resources sit in is called subscription. So as you can see, this is what I'm talking about. And subscription is where for example, your credit card is attached to. So I have a Visual Studio Professional subscription, and I have a credit card attached here, and I'm going to create a resource group. A resource group is basically a collection of resources. Now, my Kubernetes cluster needs to sit inside a logical container, and this resource group is that logical. Okay, now let's call it dev.kubernetes.doc.community. Normally, please don't name your resource group this big, but I'm doing it. One more time, dev Kubernetes community. Okay, so now I have a resource group, which is a logical container created, and now we're going to call dev. So let's call this cluster. No, we'll call this cluster production. And I'm going to spin up this cluster in a region because I live in the Netherlands. West Europe is the closest region to me, so I'm putting that on, and it basically says the availability zones being checked in. The availability zones are, okay, so these are zones upon which your cluster nodes will be spun up in such a way that if one of the rack server goes blown off, your cluster can still be made available via another node belonging to an availability zone. So an availability zone will be a cross-section of different servers belonging to different layers of network, compute, and the other infrastructural connectivity. So this is going to run the Kubernetes 1.19.11 version, which is fine. And then it is going to talk to me about how many nodes do I want. Because for the sake of demo, I'm going to just say one. And then this is basically the size of the computer that you would want. So it talks to you about what kind of VM size. Do you have compute-intensive workloads? Then go for a higher VM size with more compute, with more memory. If it is if your cluster is not going to perform a lot of compute-intensive workload, then you can choose your VM sizes accordingly. But now let's go ahead with DS2 V2. I'm not going through a lot of steps in between node pools, authentication, network integrations. Basically, you're done here. You can create a cluster and get started, no problem, right? Node pools are basically the number of virtual machines. So you remember from the iPad how the kubectl orchestration layer sits on the top of several computers. So here, basically, you tell the Azure portal as to how many nodes, how many computers you want. And then next, we are talking about authentication. So whether do you want an identity provider to be linked to your Kubernetes cluster? So for example, let's say we have Azure Active Directory, which is an identity provider, and that can be integrated to Kubernetes cluster. So the way you log in and access to your Kubernetes cluster is being governed by the permissions that you will configure on your identity provider. Let's break it into simple terms. Let's say you're logging into your Facebook account or to your Twitter account. The identity for your Twitter account is provided by Twitter. And imagine Azure Active Directory is replaced with Twitter. Then I say, okay, from Twitter, my connections, Bart, Farrell, and 2 other users would have access to my Kubernetes cluster. Then I basically use Twitter as an identity provider to manage my authentication for the cluster. So this is the story around authentication, and networking basically tells you whether you need to go ahead and use the KubeNet, which is the network component that comes as part of the default Kubernetes cluster, or do you want to use the Azure networking component? And integrations, you can always integrate your Kubernetes cluster to a container registry. You remember we spoke about I have an app which can be containerized. And if you have an app that can be containerized, we can also imagine that containerized app is hosted on a container registry. It can be Docker, for example, and you can connect it here. So then we have tags review, but basically you do not have to go through all of those steps. The platform takes care for you and does the default configuration. But just in case you're wondering what those 4 tabs that I just overpassed, those are the definitions. So let's go and say create. And in some time, it is going to spin up a cluster with the definition we just gave. And as you can see, it has already started progressing. However, due to the interest of time, which all of us have a very limited capacity, I'm going to go and switch to the other resource group I just created before joining this call, and that's called DoK community. And if you look into that DoK community, because I told you this Azure Kubernetes service is a fully managed service, all you get is one resource that is called Kubernetes service. Well, there is an asterisk here. We'll get to that later. But what we need to know, so this is the cluster. And when it comes to the cluster, okay, so now we have a fantastic cluster spun across multiple computers, which in this case is one node, of course, but which practically can be spun across multiple computers. And now I have an infrastructure ready. Now you need to run your workload, isn't it? How am I going to run my container? So let's go and look for workloads. When we spoke about the how part of Kubernetes, we spoke about deployments, right? Which is the fundamental unit of narrating to the Kubernetes cluster as to how you need to run, what you need to run. So this is what we see here. And then we've got pods, we've got replica sets, stateful sets. We did not go through in detail about stateful sets, daemon sets, jobs, or cron jobs, which I'm going to do it in the closure. But for now, all you need to know is the how you can get started on this Kubernetes cluster by deploying your first workload, right? So what you practically do is go, okay, one more time. Kubernetes cluster, go to workloads, and we are in deployments, click on add. And this interface basically is a text editor, which is asking you to put in your YAML, your declarative information. So if you go to my VS Code, so what we're going to do is basically deploy a voting application. This is a default getting started example that's on Microsoft Docs. So you can take a look at it. So what this app does, it allows you to vote either for cat or dogs. So do you like cats? Vote for cats. Do you like dogs? Vote for dogs. That's about it. And it is built in a way where you have a front end, where you have a back end, and the back end depends on a Redis container and it persists. Now we're going to talk through how that declarative instruction is, right? So let's focus only on the first 32 lines. Too much, isn't it? Nah, let's close it. Too much. So when it comes to Kubernetes, there are only 4 fields that are important. One is API version, kind, metadata, spec. So what are these parameters? So basically, when we started, if you remember that iPad drawing we made, we set this Kubernetes layer, this orchestration layer, which is spreading across multiple nodes. It is exposing its API via kubectl, which is one way of executing, interacting with the Kubernetes, right? And that API definition expects you to mention what API version of the cluster are you trying to use? What is the kind? Because we spoke about deployment. We also spoke about jobs. There are daemon sets. There are stateful sets. So what kind of workload are you trying to execute on the cluster is what we mentioned. And then some metadata about the workload. So metadata is actually data about data, right? So in this case, like I told you, it's a simple voting service. So I'm going to put some Azure, okay, I'm going to give a label called Azure Vote Backend, which has the following specification. You remember we spoke about how the cluster behaves in a declarative way, where I'm basically saying, hey, you know what? You need to select a node that runs Linux operating system, and my container name is Azure Voting Backend, and this is the container image, and then I have some environment variables, and I say what is the limit of my CPU memory. And once this information is passed on, to the Kubernetes cluster, it will start spinning the pods for you. Okay, now comes an interesting question. It is nice and all that, you're spinning this pod inside you're spinning this container inside a pod, inside the cluster, but how am I going to access this from the outside world? So we're going to see how that works right now. So basically what you do, this is the backend. So this is the YAML definition for the backend. And then there is a service definition for the deployment we just made. And I will talk you through what exactly that service definition is. And then there is a front end which interacts with this backend, which also has a service definition. So all in all, we've got about 95 lines of code. So Control A, Control C, put it here. And when I say add, it will start. The declarative message will be passed on to the Kubernetes cluster, and then it will start deploying. Again, in the interest of time, before the call, I deployed those containers. So we're going to interact with the kubectl API to figure out what has been deployed onto this cluster. So entering into my Azure Portal from the CLI, and it is requesting a terminal. So give us a moment. Yay, we are there. So what we need to do is, I'm trying to ask, hey, kubectl, get me all the deployments I did on your cluster. And it takes time. As you can see, there is an Azure voting front end. There is an Azure voting backend. So there is a voting application with a front end. There is a voting application with a backend. But we also spoke about services, isn't it? But why do I not see it? Because you only asked for deployment. We did not ask for services. And if you look here, this is kind deployment, and this is kind service. So the service is the unit which is going to make this container accessible to another container internally or to another external traffic coming from the outside world of this cluster. So if I do kubectl get service, so you can actually see there is the service endpoints that are returned by the kubectl get service command. And what we are interested is the is the external IP for the voting front end, because it's the voting front end application which has a load balancer and therefore has an external IP which is accessible. And now let's say new tab, put that IP address, let's go, bingo, we have a voting application. So this voting application, basically what happens from the external world, when I put on this IP, This resolves to the public IP address. This resolves to the Kubernetes cluster IP, and from the cluster IP, it reaches out to the ingress controller, and from the ingress controller, the service definition says where exactly this app is running within the cluster. So cats, dogs, and if someone who's watching this before I click on reset would put on the same IP address on your browser, you're going to see the same state because the state is being persisted on the backend. Now, let's say I cannot give people this IP address, right? So it's going to be hard. So let's go buy a domain. So I bought a domain, just like every developer does. I went ahead and bought yet another domain, and that's called purpleginger.xyz. And right now, this purpleginger.xyz has an A record which is pointing to the IP address we just created. So if I now copy purpleginger and put it on, so what basically happens, purpleginger goes to the DNS provider, the name server resolve it to the public IP of the service, and that service is running on the Kubernetes cluster, which in turn can effectively point. So if you can see, which in turn, what happens when we do purpleginger.xyz basically points to this service, which is a load balancer, which basically does a selection on the Azure voting front-end app, and that resolves back to this deployment, which is a pod running on a container running within a pod in the Kubernetes platform. And that is how the resolution from the outside world to the inside happens. While ideally in production, there are going to be a lot of extra components that will get into the picture, but then the fundamentals does not change, and this is how it basically works. So this is, in my opinion, quite a primer to get started on the Kubernetes journey. And I think from here on, it would be quite easier, I believe, to go through more advanced concepts on Kubernetes. So as a wrap up, what did we do? So today, the idea was to go through day 0, Azure Kubernetes Service. We spoke about what Kubernetes is. It's a, fully managed container orchestration platform. We spoke about the principles, declarative versus imperative, how it supports workload portability. And we also went through some concepts, pods, which is a collection of co-located containers, replica sets, services, deployment, stateful sets, and jobs. I told you I will explain what stateful set and jobs are, which is another workload type on the Kubernetes cluster. Stateful set is nothing but, just like its name suggests, it allows you to run stateful application. It works in a way where it can persist state right inside the pod where the container is running. So if you're running stateful applications, say, for example, I'm running an ingress controller and I need to persist the state of all my routing information. Bingo, let's go ahead and spin a stateful set. Or I want to spin up another type of a workload where, there are like 200 photos in some storage container in my Dropbox, in my Google Drive. All I want this job to do is, my Google Photos subscription is terminated. There's no free storage available anymore. So I will run my script, which will go connect to my Google Photos app, collect all the photos, put it on another container. Let's say you have a job like that and you want it to run. You don't want it to run continuously, you just want it to run once. Then you basically run that workload as a job on the top of Kubernetes cluster. All in all, the platform allows you to run different types of workloads, therefore helps you to accomplish a lot of different kinds of things. So you could create value for your end customers by delivering any one of these workload types. So when it comes to Azure Kubernetes Service, Azure manages the control plane for you. So the API upon which the Kubernetes layer itself runs is being managed, and the nodes on where the containers would run is being offered to you for accessibility to do, things of your choice. But don't try to mess with it. And this is mostly the idea behind day zero, Azure Kubernetes service. And thank you so much for being with me.
Oh, fantastic. That was wonderful. Now, a couple things just to keep in mind. We got some questions during the talk. For starters, all right, this may be a little bit uncomfortable, but in our community, we try to be as open and transparent as possible. And I'm sure this is something you've been asked before. If we're talking about, the options that are out there, because, some folks get a little bit overwhelmed, like, do I want to go for Azure? Do I want to go for GKE? Do I want to go for EKS? Principally speaking, in your opinion, what are the differences? What is the best use case or users, consumers for AKS as opposed to those other providers?
This is a fantastic question. There is no right or wrong answer here. It is the Kubernetes platform as a whole. It is open source, so it is heavily being contributed by the community. And there is, let's say, if your team has a lot of background on the Microsoft stack and your workloads, your other engineering workloads are already running on the top of Azure. Say, for example, you're using Logic Apps, you're heavily invested on Azure Active Directory, and a lot of other integration services on the Azure platform, then maybe Kubernetes on Azure platform is a better option because you do not have to build a lot of connectors yourself. A lot of things are available outside the box. But again, this is only a guideline. I wouldn't at any point in time, would push a particular platform or a vendor towards the customer. I think in principle, it's more about capability of the team, and if they are comfortable on the Microsoft platform, please go ahead and use it. In the otherwise, it's actually a free choice. At this moment, I'm not able to think of a reason why I would position one platform more better than the other. And I do not have much visibility into GKE and EKS, so I'm not able to comment much there. But wild guess, it shouldn't matter.
And I think that's interesting, as you said, keeping in mind that open source mentality, and we are getting to the point where we're seeing cross cloud, hybrid cloud, multi-cloud, this kind of approach. So it's really about a cloud native mindset where we're not so focused on the vendor and we're more just focused on what are the things that I need to exactly what are the things that I need to be doing. With that in mind, as someone who's worked as an SRE, what do you think? Because as you were talking about the capabilities of the team, and you said previously, which I really liked, is that for a lot of folks out there, it gets really overwhelming of like, oh gosh, I have to learn this. I need to know this. To know that, I need to learn this. In terms of your personal journey, because you've been working for a while as a platform engineer, got tons of experience. What were the things that helped you when you started working with Kubernetes?
Okay, one of the first things that helped, there's this gentleman called Saad Ali, who is a senior software engineer at Google. And he has a fantastic primer that talks about the principles behind Kubernetes. I think the way things that settle in my head, like you said, sometimes it's so overwhelming. Technology stack keeps changing every single day, and it's really hard to keep pace with all of these topics. So I rather try to focus on why we need to choose something we are being asked to choose in the first place. So I try to research on the why aspect of it. And those content help me to learn and understand the platform better. In that respect, I would definitely recommend the talk by Saad Ali, where he narrates about the design principles behind Kubernetes. So once that why part is embedded so strongly on your head, I think then that gives you an idea as to why you need to solve a problem a certain way. And then you're naturally curious about how you need to do it. And then the learning journey takes you on its own and without you trying to do much.
This is a great point.
So that's the starting point I would recommend.
Now, good. Now, also as well too is that having worked in where you were before and now going to your new position is thinking about how decisions get made. Like we often see is the push, the pull. Are is it CIOs and CTOs that are pushing for Kubernetes adoption? Is it on the other side where it's coming more so from developers? You've been an SRE. How was it in your case?
All right. So I think every organization is different, and maybe there is not a singular pattern, so to speak. I think in most cases, from what I've heard in terms of experience, the mandate usually comes from the team. So there is usually a senior engineer that's coming in from another organization where he has done that, executed, sees value, and he pitches it to the leadership. Hey, come on, guys, we need to invest on this platform, and we need to reshape our platform strategy. And then from there, it is being picked on. But definitely, without the backing of the leadership, because it's quite an investment to put your engineering team to construct a platform, to remodel your services to be able to run on the top of this platform. And therefore, it's also an organizational mindset. So the way I see it, it always starts, the motivation starts from engineering, but the execution aspect of it in terms of budgets and all the financial angles and the organizational mindset that has to change, because every business needs to invest their time and effort to remodel their applications to be able to run on the top of a container platform. So maybe or maybe not they get new features, then they will have to understand, I will have to sacrifice a period of time so my app can be modernized and be able to run on the top of the cluster, and they are not immediately aware of the benefits. And therefore the push starts from the engineering team, but then it is broadcasted and at an organizational level from the leadership, I would say.
Yeah, I think that's a really, really good point. And like you said, is that the time, let's say the time that's necessary until you start seeing a return on that investment, I think that is something that might be uncomfortable, or something that just needs to be better explained in the context of that transition to working with Kubernetes. And we live in a very quick fix world. We want plug and play. We want to see results immediately. But like you said, the cultural changes, the capabilities of the engineering team, there is that learning curve, the adaptation period that is going to take some time. And
totally.
The thing is, and you've been around technologies for a long time. So when a technology is 7 years old, normally we might think of something like that as being mature. I guess at the same time, if we think about a child that's 7 years old, there are some 7-year-olds that are more mature than others. But I would say that Kubernetes, it's fun if we think about it that way, right? It's because Kubernetes is still very much in an early stage in terms of maturity. In terms of, you talk to lots of different organizations. I don't know how it is in the Netherlands, but normally I'm in Spain, and there are plenty of organizations that aren't aware or aren't even thinking about Kubernetes. Maybe they've heard about OpenShift. Maybe many more would be working with containers, Docker, etc. But I think we're still very much in an early period. You're talking about day 0. We've had some talks about day 1, even day 2. But if technology is 7 years old and we're still not even at day 3 or 4, I think that says some interesting things about the technology. What do you expect to happen in the next few years with Kubernetes in terms of its adoption at a global level, perhaps simplifying some of these things so it's not so overwhelming? What do you expect?
Okay, so whenever a question in terms of what do you think will happen in the next couple of years, well, the best way to predict that is also to look back and see what has happened in the past, right?
Great point.
One singular thing that has happened continuously in the past is how things. One of the best things that software engineering organizations have been so good at is abstracting things. So we started working with relays and switches. We went to transistors. We went to logic gates. We went to processors, microprocessors, and every time there is always an abstraction. Our compute is being abstracted to a higher level. What I'm expecting in the next coming years to happen is the entire idea of Kubernetes is being abstracted even farther away, and maybe the serverless aspect of Kubernetes can evolve even further. So at the end of the day, the idea is how quickly can I create value for my end customers? And okay, so Kubernetes allows you to have a unified and a repeatable DevOps pattern that reduces time. All right, great. Is there anything else more? Is there anything else can I do to solve the time that is taken for me to convert my concept to ideas? If I think in those terms, I think maybe serverless is another potential candidate which can, which can be embedded into the idea of Kubernetes, and that could progress more further. And the adoption across geographies would increase. At 7 years, at least within the community in the Netherlands and even outside, the number of community events, the number of people that talk about it have gradually increased. I think there is still one problem though. The value of adopting to a platform engineering experience, maybe it is not being very clearly communicated. So I think that is one challenge. So I think we will get better at representing value of adopting to a platform as such in very clear, tangible metrics. And the next to that, in terms of tech, I think serverless would be another paradigm shift that will happen on the Kubernetes world.
I really liked what you mentioned right there about the experience aspect, because that we this is kind of spun up from starting with user experience, customer experience, developer experience. I think it was this year there was there was going to be a developer experience conference, and so I think that's getting bigger. And so thinking about that is that, are we talking about technology or the experience working with that technology? They kind of go hand in hand. But I think, like you said, as those conversations get more and more out into the open, we sort of take away this scary layer of, oh, you can't do it, or it's too difficult, or you need 30 years of experience. I think that's a really, really good way of looking at it. I think also as well, too, what I find particularly interesting about SRE is exactly as you said, is because for me, if you're talking about SRE, obviously depending on the size of the organization, but generally global ones, you're talking about global geography. You've got to have on-call shifts, alerts that are ready to go for someone that's going to be in different countries. We're coordinating things like that. So because of that and those shared experiences, I think those things are getting healthy conversations out in the open about how this needs to be tackled so that it's not as frightening for organizations when they decide to make that jump. That being said, you recommended a couple of good resources from Saad Ali. I've looked that up, and it looks really, really good, as well as his 101 about storage, which looks interesting too, because that's obviously a very big thing, particularly if we're talking about stateful sets. Where is this data going? How is it being managed? Is it resilient? Is it safe to be transported? Transporting data can get tricky. But in terms of other resources, any others that you would recommend that have worked for you in your experience?
Well, there's one more that talks about how you can do a Kubernetes learning journey in about 50 days. Maybe I can look it up.
Okay.
Put the.
I mean, that's the thing as well too, is that there are many resources that are out there, and so that sometimes gets a little bit. Is start with one, and you'll be okay.
So I actually like the Kubernetes learning path from Microsoft. While I'm still not officially onboarded.
Wearing the hat.
So I still can independently vouch for this content, and I really like it. So where I should look for the chat, and I'm putting the URL right here.
Perfect. Yeah, if you just drop that in there, we'll put that in our Slack. Very good. Awesome. Go ahead.
That's another one that I like. That's what I was going to say.
Oh, that's good. No, that's good. Well, if it's good enough for you, it's good enough for me. Can I ask you actually to stop sharing your screen, because we have a little
I did already.
Okay, you did already. We have a little bit of a tradition every time we're finishing a meetup. It was very coincidental that when we got started, you're like, hey, I'm going to use my iPad, because like I said, this is the first time someone's done that. We've had other people use some drawings, but generally they're already done and then they bring them on here. But to have someone doing it live, and particularly, freehand, was really cool, because in all of our meetups, we have a graphic recorder, and let me know when you can see my screen.
Whoa!
Yeah. So while you've been talking, my great friend Angel, who's in Spain, he's been drawing the stuff that you've been talking about. So that's why I didn't want to tell you when we got started, because it's always a nice touch. So this is a wonderful way, and that's why I think it's so cool that you use the visual learning aspect of it. Everybody learns in different ways. Some people like documentation, some people like videos, some people like podcasts. So as a community, we try to offer as many different learning opportunities, because there are people that learn in different ways. So anyway, that's Angel's depiction of what you did, and I think you did pretty good. Yeah,
I'm like, boo.
Yeah. No, but we are too, because like I said, it was so cool. And so he and I have been talking when this got started. I was like, hey, he's going to be drawing. So anyway, this worked out really, really well. I would love to have you back on. Congratulations
Absolutely.
on your transition to your new job. But this was great. And, we've had tons of different perspectives on Kubernetes. You can never go over the basics too many times. Also, your perspective of having been an SRE, now moving into the position of a solutions architect, very much focused on solving problems, helping people, is wonderful for us to have. So that being said, if it's okay with you, I would like to continue the conversation in Slack because we had a few questions that we couldn't answer. But thank you so much for your time, Raj, and I hope to have you again.
But thank you for all the positive energy. I think I owe as much as of what the session was today to the energy that you brought to the table.
Oh, that for me, that's anytime, whether it's a Monday, Sunday, you got it. So anyway, Raj, very nice to have you on. Hope to see you in the Netherlands at some point. I would love to get back to Apeldoorn. That being said, enjoy the rest of your day and we'll be in touch.
Absolutely. Very nice
All right,
meeting
take care.
you and the community. Bye-bye.